We are going to present this product, which is a good part of the result of a collaborative project between PREMO universities and technology centers. It's the development of an antenna, what we call primary coil, to transmit wireless energy for electric vehicle wireless charging. Basically, we are going to present the main innovation of this product, which is the magnetic core inside this pack. This is a technology similar to that used in induction cooking. The magnetic induction energy is used to transfer the energy from the primary coil that is in the infrastructure on the ground to the secondary coil, place it underneath of the vehicle. This is an innovative design where we have generated the high performance, flexible and robust magnetic core at the best possible cost effective in comparison with current standard core used in this type of wireless power transfer application. In other words, we are facing an important innovation from the product quality point of view for the intended application in the automotive environment. So basically, we are talking about three important contributions. First of all, the lightness in comparison with other standard pads in the market. We are talking about a significant weight reduction beyond 20-25%. Therefore, the weight of this coil is around 5 kilos. The ferrite core, made of a high permeability, low losses material with a concave convex lateral design, whereby this ferrite can be joined without gap, turning into flexible. There's a similar concept of watch chain providing a robust and flexible characteristic. Secondly, it would be the magnetic core, a flexible and unbreakable core due to the characteristics of the design, size and shape, and the material used in its construction. Incorporate an innovative magnetic materials called PBM, that is polymer bonding magnetics, which is a flexible resin with a high load of sintered magnetic powder particles of different sizes to fill the areas of the free areas between the ferrite tiles, able to redirect the magnetic field to minimize the total core losses. Finally, between the magnetic core and the heatsink or the aluminum shielding located at the back of the coil, there is a gap, typically between 1 and 3 millimeters, and this gap is filled with a special thermally conductive compound, also flexible, called Coolmag, with a thermal conductivity between 1.5 and 2.5 watts per meter Kelvin, which acts as a low resistance path for the heat generated in the coil and in the magnetic core to the aluminum shielding plate. Take into account that this coil can work up to 11 kilowatts for the power transfer between the charging station and the vehicle, primary and secondary. It also follows the generic design, size and performance, including interoperability of SAE J2954 recommendation, a global recommendation specifically released for a wireless power transfer in vehicles. These three factors, together with the coupling factor, provide an energy transfer efficiency above the minimum required by the SAE J2954, which is 85%, thus offering an efficiency that can be between 90% and 95% depending on the gap between primary and secondary coils.